Hi guys, so in this video we are going to talk about measles, but not so much measles, more what happens after you get measles. We first talked about measles a while ago back in your Cameron-Thompson cases in host defense, host response, but measles, along with a whole wide variety of other infectious diseases, can cause a post-infectious encephalitis, and that's really what we're talking about here, because more than measles, what we're talking about is SSPE. Which is subacute sclerosing panencephalitis, which is one of the things that we don't see very often, thankfully, but is associated with measles. Measles virus, also known as rubeola, is one of the 5 childhood or classical childhood exanthems, including rubella, roseola, fifth disease, and chickenpox. Historically, it was one of the most common and unpleasant infections. Prior to 1960s, more than 90% of the population under the age of 20 were infected. And so it was really common. But then now we have a really great vaccine. It is a vaccine eligible illness. So it is one of the M's. It's actually this M in the MMR, or now the MMRV vaccine, which is one of our live vaccines. So this, sorry, we're talking about this one, this first M, measles, mumps, rubella, and varicella. So this is the first M in the MMRV vaccine. And it works very well. So we really don't see it all that often. Unfortunately, though, this is one of the vaccines that came under kind of the most scrutiny with the kind of anti-vaccination wave that came through. And so we have seen an increase in measles. In 2017 alone, there were over 100 cases in the United States. And that's actually down from in 2014 when we saw over 600 cases. So even though it's a vaccine eligible disease, we do still see this one from time to time, particularly as kind of herd immunity wanes. Okay, so let's do a quick review of measles in case you guys do not all remember it incredibly clearly from back in October. So first off, like I said, we learned this in Cameron-Thompson. It was actually Cameron-Thompson Part 2, where she was dehydrated in your host defense and host response block. I didn't have a separate measles video. Instead, I relied on the osmosis video, so you can check that out. But here's just kind of some highlights of measles, the condition. First off, this is a highly contagious virus. Remember I said on the last slide, greater than 90% of patients were infected with measles prior to the vaccination. So highly contagious. It's spread by respiratory droplets, and then it can quickly lead to a systemic infection, which is part of why we're talking about it in the brain and behavior block. So basically what happens is that the person gets infected through respiratory droplets, and then it infects monocytes and lymphocytes, and that leads to dissemination throughout the body, including viremia. We can detect the virus in the blood of infected patients here. We especially expect to see infection in a couple of places, certainly the respiratory tract, because that makes sense, right? That's where we're initially getting exposed, we're breathing it in. The conjunctiva is a very common place to find infection. We'll also see it in the urinary tract, small blood vessels, like I said, we see viremia, and certainly the lymphatic system. Remember that it's able to go kind of systemically because it gets into those monocytes and lymphocytes, which are able to travel throughout the body. Most people recover pretty quickly, but occasionally we do see patients die from things like pneumonia, diarrhea, and encephalitis. The incubation period for this one is about 1 to 2 weeks after exposure, and then it has a very specific pattern of disease. So we see kind of this prodrome, you know, your standard viral prodrome, fever, myalgia, arthralgia, fatigue, things like that. But then you get what are called the 3 C's and a P of measles. I know it's not exactly the most catchy title, but that's what we call it. So the 3 C's are cough, coryza, and conjunctivitis, and then photophobia is the P. So when you see those 3 together, that's normally a good indicator. So basically what happens is your patient gets infected. 7 to 14 days later, they start feeling kind of bad. And then within 2 days, you start to see the remainder of these symptoms, cough, coryza, conjunctivitis. Additionally, you can see very specific signs of measles that are practically pathognomonic for the disease. Particularly here, these are called Koplik spots. Let me see if I can find some to point out for you. So if you look here, these like little grain of salt-like looking things on the buccal mucosa across from the molars, those are Koplik spots. They'll appear about 24 hours after the Koplik spots. You're going to see this. This is the actual exanthem. It's going to spread across the entire body, including the hands and the face. This isn't one that spares the hands and the face. We're going to see it everywhere. And these signs together basically indicate to you that your patient has measles. So very specific kind of timeline and behavior in this particular viral infection. Now, I said it goes systemic, and when it goes systemic, we have to worry about the brain because it actually does have some fairly significant repercussions for the brain. Okay, so I'm talking about the concept of post-infectious encephalitis with measles, but really it could happen with any of them. This occurs after a lot of viral infections. We talked about it in your meningitis and encephalitis case with HSV, right? Because HSV leads to encephalitis. Where? Think temporal lobes, right? Nobody's ever forgetting that, right? Yeah, okay. Told you I was going to work it in every chance I could. But we also see it with influenza, right? We can see meningitis and encephalitis with influenza. We haven't talked about rubella yet. I'll likely do that in your M2 year, but rubella also can lead to that. That's caused by the ruby virus. It's another RNA virus. Varicella can. All of these infections can lead to some sort of post-infectious encephalitis. Now, what do I mean by post-infectious? That should be pretty easy to figure out, but just in case so that we're all on the same page. I mean the infection has resolved, but we're still responding as if it's there. So that's why it's presumed to be somewhat autoimmune in mechanism. You're no longer responding to the infection, but your body is still reacting as if the cells within the central nervous system are infected. Mumps is actually a big one for this one, the mumps virus. In this case, we can have an infectious encephalitis, where there's direct viral infection and damage, or you can have a post-infectious, which is more like a meningoencephalitis in the absence of the virus. And the other place we see this is particularly with measles. So with measles, we can see it in a couple of different ways. Just like with mumps, we can see a direct infection, but we also see a post-infectious encephalitis as well as this SSPE. So about 50% of patients with measles will have no symptoms but may have an abnormal EEG. So they don't have any symptoms, nothing cognitively appears to be going wrong, but if you did an EEG, it might be abnormal. And that suggests that the virus actually reaches the brain. Encephalitis occurs in about 1 in 1,000 measles infections. So not all the time, not very common, but we do see it from time to time. Post-infectious, as I mentioned earlier, is typically immune mediated. So the disease process involves the sensitization of the infected person to myelin epitope that results in demyelination, or in this case, it actually leads to a loss of neurons. So we're going to talk about subacute sclerosing panencephalitis. This is a very, 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 very rare post-infectious sequelae of measles infections. It actually only occurs in every 1 in 100,000 cases. So even when at the height of measles, you weren't seeing a ton of SSPE patients. Okay, so right about now, you're all asking yourself, Dr. Richards, if it's so darn rare, why? Why are you teaching it to us? Why is there a whole slide to it? Why? The boards love it. This is what I am told over and over again. I check STEP every year. I check the records every year. SSPE is still on it. So even though it's almost impossible, knock on wood, that you will ever see a single SSPE case in your whole lives of practicing, you might see your only SSPE case on your boards. So that's why I'm talking about it. It's extremely rare nowadays, but it used to be a little more common. It is very specific to measles. Much like the other things with measles, it has a very specific kind of timeline to it. This one is going to occur about 10 years after the initial infection. So remember, the infection is gone, but we're still kind of behaving like there's some sort of pathogen that we need to get. So before the vaccine, we would have roughly 250 to 500,000 measles cases a year in the US. Most of your parents and grandparents had it. and SSPE would occur, every so often. So if in the US you had 400,000 cases, that means you might see 4 cases of SSPE in the year. Right now, if you tried to catch 400,000 people with measles in a year, you'd be waiting a long time because the vaccine is good. So what happens is a patient gets measles, and then 6 to 10 years later, they start showing symptoms. And the thought was that there was like a defective measles virus, since we couldn't isolate the virus for those 7 to 10 years later, and that the mutant virus gets in and damages the cells. The symptoms for this one are pretty obscure. Personality changes, impaired memory, declining performance in school or work. Now, here's the problem with these things. Your average measles patient was getting it somewhere between like 2 to 4 years of age the first time they saw it, okay? So let's say we have a 4-year-old who gets measles. 10 years later, well, those are teenagers. Teenagers are practically non-human. You're a kid, and then that becomes a teenager, and a teenager is a totally different species altogether. Then around 21 to 22, you become human again. So of course there are personality changes, but the parents just think, oh, it's puberty. He's just rebellious. He's hanging with the wrong crowd. All right, so his personality changed. Then we go impaired memory. Okay, but kids forget everything. I mean, they forget things right after you've told them. Declining school performance, well, as a kid goes from junior high to high school, classes might get a little bit more difficult, attitude might not be as good, so the kid starts getting C's and D's. And that generally becomes like the red flag to parents where something is going on, because parents typically care about school. But they don't necessarily think SSPE. So they bring them into the doctor, and the doctor thinks, I don't know, this could just be something social. The big clue with SSPE is actually handwriting. I know this sounds very strange, and I don't know how we're going to assess it now that we're not necessarily focusing on handwriting as much anymore, but it's a big key. A kid will have readable handwriting all the way until they start to get these changes. Then all of a sudden, their handwriting just becomes like scratches. And it's not even readable. I don't know how we'll test this in the future, but that was kind of the big, might be SSPE. And that normally gets them into the doctor's office. Normally the doctor finds nothing, and then things start to go really bad. Patient develops seizures, paralysis, coma, and death. This all occurs within months to a year. And it's fatal pretty much every time. Diagnosis is made basically by EEG, symptoms, and a history. If you have a history of measles infection, we look at the CSF and the serum for a really high IgG titer. And that's, kind of all we can do. There's not going to be any detectable virus in there, but there are very high levels of anti-measles antibody, which is what is causing disease in the brain in the first place. If we look at it microscopically, which I'm showing here, you're going to see perivascular infiltration of vast numbers of leukocytes all over the brain. Other things you might see are like neuronal degeneration and intranuclear and intracytoplasmic inclusion bodies. And the measles virus antigen is actually present in the brain, and later during the course of disease, you might see some evidence of demyelination. So remember with SSPE, this is a post-infectious encephalitis, so probably some sort of defective, incapable of replicating virus. We're not actually responding to the virus anymore. This is most likely immune mediated. It happens about a decade after, and the big clue is poor handwriting with behavior change that leads to seizures.